You can answer in the chat box also. You just don't keep mum. So pointers in C. A formal definition of it is a pointer are the special variables that are used to store address rather than a value. Okay, these are special variables which are used to store only addresses. The address can be of any variable. The address can be of a integer variable, it can be of float variable, it can be of an array variable, it can be of a structure variable, it can be of a function, it can be anyone's address, but this variable holds only address. There are two things which you'll have to always keep in mind as far as C pointers are concerned. What we do, you remember two symbols. One is a asterisk symbol, another is a ampersand symbol. All this symbol, always pronounce this symbol as value add and pronounce this as address of. These are the two things which you need to keep in mind as whenever you are dealing with pointers. Now I am declaring a pointer variable here. So this means P is a variable which is going to hold only address. Address of what? Address of a variable of type integer. Okay. P2 is a variable which will store address. Address of what? A variable of type float. Okay. So this thing you need to keep in mind. So whenever I declare a variable with the symbol asterisk, it makes that variable a special variable. Special in what sense? It can hold only address of some variable of any type. And what this type defines, or even I can have character pointer C. Character pointer C is going to hold the address of a variable of type character. So what is going to happen? Uh, Let us move forward further. Just remember these two terms. Asterisk is value add and ampersand is address of symbol. So let us try to say this. What will happen here? There are two variables which are declared, PC and C. There are two variables which will be declared, PC and C. So of course, what you know what happens. As soon as we declare a variable, there will be a block of memory allocated to it. This block of memory will be maybe of 2 bytes, 4 bytes, depending on the variable which I am using. So, and this will be named as C, another will be named as PC. I am declaring two variables. Let us say that location at which C is stored is 1000. Location at which PC is stored is called as is assume it as 2000. Okay. Now, what is the difference between C and PC? C is a normal integer variable, so it can hold any numerical value, maybe positive or negative, which falls in the range of integer. Whereas PC is a pointer variable.
Sir,
Yes.
sir, your screen is not visible.
Is it the case with everyone else?
No, sir, it's
No,
visible.
sir, it's visible.
Visible,
It's
sir.
visible.
No, sir,
Yeah.
it's visible.
मैडम
Visible, sir.
आप re-login करो, rejoin करो आप. जिसको screen
Okay, sir.
visible नहीं है, please rejoin. So आप rejoin करो. Fine. Coming back to this, so we are declaring two variables out of which C is a normal integer variable and PC is a pointer variable which is holding address of an integer variable. So now C is initialized to 5. This will be a value 5. So what is value of C is 5. What is address of C is 1000. Okay. is 1000. Address of C is 1000, value of C is 5. Address of PC is 2000, value of PC is not yet defined. Now I am coming to this statement. So PC is equal to address of C. What is address of C? 1000. So PC is going to hold value 1000, which is address of variable C. What is PC? PC is a pointer variable which will hold the address of an integer. Is it? So PC is holding 1000. 1000 is the address of C. C is the integer variable. Okay. So this way the pointer works. Now what is value of C? Value of C is 5. Value address of C is 1000. So C is equal to 5. Address of C is equal to 1000. What is address of PC? 2000. Address of
2000.
PC. I am reading it as address of. What is value of PC? Is what is value of PC is 1000. Okay. And now what is value at PC? I am reading asterisk as value at. So it will be what is value at PC? That means value at 1000 is 5. Are you understanding this? Okay. What is value at 2000? What is value at 2000 is 1000. Right? So this is the way address of and value at symbol works. And here what we are doing, we are assigning, as PC is a special type of variable, it can hold only addresses. I am directly assigning an address to it. This is not possible. PC is equal to C is not possible because C is an integer variable, PC is a pointer variable. This is not possible. That you understand. Okay, this is possible. This is possible. Even what will be possible? Value at PC I can change to say 10. And if I am saying C is equal to 10, both are very same statement. Okay, C value is changed to 10 or value at PC, that is value at 1000 is changed to 10. So both is going to have the same effect. Both are actually same. Both are actually same. Or I can also say asterisk or value at PC is C. So this way it is done. But this is not possible because these are two different types of variables. So again I am repeating. And in this previous case, P will hold the address, P1 will also hold the address, and P2 will also hold the address, but P1 and P will hold the address of an integer variable, whereas P2 will hold the address of a float variable, whereas C will hold the address of a character variable. But value of P, value of P1, value of P2, and value of C will always be an integer value, because address will always be an integer, rather positive integer. It will also not take a negative integer. ठीक है, तो ये समझ लो आप लोग. So this is the concept of basic concept of pointer variables. We'll go for further discussion, but please make me sure that the things are clear with you. Are the things clear?
Yes, sir.
Any doubt? Anyone?
Clear, sir.
So there is no doubt. We'll proceed. If you have any doubts, you can anytime stop or drop a message. So here the similar things are done. Here these three lines are exactly similar to the previous one. Here I am changing the value of C, then that means automatically value at PC is going to change. It's a simple thing which we have just now discussed. Now we'll have a small program, we'll go for a small program which will illustrate the use of pointers. We are declaring two variables, again the same variables whatever we are declared. This variable is named as C. This variable is named as PC. Let us say that address of this is 200, address of this is 100. Okay, both of them will not hold any value. Both of them will not hold any value. So C and PC. Now C is now initialized to 22. So this empty space will be replaced by value 20. Now C is 20. Now what I am trying to print? Address of C. For address I can either use %p symbol or access specifier, or I can use %u symbol. %u will always be better to use, but %p is also possible. That means it is an access specifier for an address. Okay. So address of C. What is address of C? Is address of C 100. So I am going to write 100. I am assuming 100. The addresses are not in our control because they are dynamically provided based on this free space, free location available. We can just know it after it is being allocated, but we ourselves cannot allocate it. The 100 and 200 values are just an assumption. So address of C is 100. Value of C is 20. Value of C is 20. This way it is going to print. Let us say that now PC is equal to address of C. What is address of C? 100. So what will be the value of PC? Remember, till this point PC was not initialized. PC was just declared. At this moment PC is now initialized. It is initialized to the address of C. Hence value of PC will be 100. Again I repeat, value of C is 22, address of C is 100. Value of PC is 100 and value address of PC is 200. So if I am trying to print that, what is the address of pointer PC? Here it should be ampersand. Okay. Address of pointer PC. What is the address of pointer PC? It is 200.
200.
Okay. And what is the content of pointer PC? Content of pointer PC. PC is 100. So contents of 100 are 20. This way. Now I change value of C to 11. Value of C to 11. So now this value is changed. So value of C is changed. Value at PC is changed. Value of C is now 11. Value at 100 is now 11. Value at PC is now 11. So if I am now printing, again, I made a mistake here. So if I am printing this address of PC, address of pointer PC, so it is going to print address of PC. And what is the container of PC now? Now contents of PC, it will be 11. Contents of PC will be 11. Okay, now again I am changing C. Here I am changing C. I am changing value at C is equal to 2. Value at C is equal to 2 means very equivalent to this statement. So C and value at PC are same. So now if I am printing address of C here, it is going to print 100. This value is changed to 2 now. And if now I am saying value of C, it is going to print 2. Because what I did, value at PC is changed. Value at PC is changed. So value at PC is actually C. That is value of C will be a new value. It will be 2. So this is the way we can make use of pointers in a normal program. Even we'll come to the pointer arithmetic later. We can use this value anywhere else. Like here, the statement is written as, instead I would have written it as PC is equal to let us say that C plus 2. Then what was the value of C at this moment? It was 11. 11 plus 2, value at PC, that is new value of C would have become 30. So this is also possible. Or in other case, I can also say this way. Value at PC is equal to value at PC plus 2. Value at PC is a numerical value. That's why it can be used in arithmetic value. Okay. So again, it will return 30. This way also I can use this pointer arithmetic. Will come into picture in further discussions. Right now, I hope I made this point clear. Some common mistakes. Just now what I said is, if C is an integer variable and PC is a pointer variable, this is not possible. PC cannot be equal to C. Even this is not possible. This is value at means is a numerical value, and this is address of is a address value. This is also not possible. Here the same thing is there. PC is the address, C is not. Here this is not an address, but this is an address. So address cannot be equal to some numerical value. Okay, if both are addresses, then it is okay. Like this, PC is the address, and so is an address of C. So this equivalence is absolutely correct. And if both are values, in this case, this equivalence is also correct. This is going to be true. So just please remember, you are not making these mistakes. Rather, only these two mistakes. You always make sure that you are assigning address to address and assigning value to a value. Now see this image. Any doubt? If you have any doubts in between, please post them in the message. Otherwise, I'll just think that you are understanding and I'll go ahead. So, which will be a problem for you because mind well. If pointers are not clear, data structure is absolutely not clear. You will be struggling to understand data structures. It will be very difficult for you. It will be very difficult. So please make sure that you understand pointers, basic concept of pointers. Now, an integer variable number is declared. So what will happen once the number is declared? A memory space will be allocated. Let us say that it is allocated with address 1000. So value of num is 10, address of num is 1000. Okay, so value and variable it is given here. So value of num is 10, address of num is 1000. Now next variable is declared ptr1. Let us say that it is holding address of num. So what will happen now? What is the address of ptr 2000 and what value ptr1 will hold is 1000, which is in turn is the address of num. Okay, so here num is an integer variable, can hold any value of type integer. ptr1 is a integer pointer, means pointer to an integer. It can hold address of a variable of type integer. In this case, it is holding address num, which is of type integer. So ptr1 will hold address of a variable which is of type integer. That's why it is called as integer pointer. A pointer is pointing to an integer pointer. Okay, so it is going to happen this way. So address of pointer ptr1 is 2000. Value of ptr1 is 1000, which is address of num. Now, forget about the first part, just see this part. Even though it's a pointer variable, but it is also a variable. That variable is stored in some memory. If it is stored in some memory place, memory location, that means it is having an address. So if it is having an address, we can store that address also in some other variable. But that should also be a pointer variable. That should also be a pointer variable. So here it says that PTR2 is now having two asterisk symbols. One asterisk means pointer to an integer. Two asterisk means pointer to an integer. Okay, one asterisk, two asterisks, and an integer. So pointer to an integer. Pointer to an integer. Pointer to an integer. So what it says that if this variable is declared, it can also it is going to have an address, and this address can also be stored in a pointer variable in this way. I can simply say address of PTR1 is stored in this variable. Okay, so it will look something like this. It will look something like this. Now what's happened? PTR2 is holding address of PTR1. It is 2000. This is the address of PTR2. So now this variable, so this is an integer, this is a pointer to an integer, and this is pointer to an integer. Okay, this is a pointer to a pointer, which is a pointer to an integer. Okay, so I have a pointer to a pointer, I have a pointer to an integer, I have a pointer to a float, I have a pointer to a pointer. I can also have a pointer to a pointer to a pointer to an integer. Likewise, let us say that I am declaring one more. I am declaring it as asterisk, that is star, or pointer PTR4. Sorry, PTR4. Sorry, PTR3. As PTR, and which holds the address of PTR3. If this happens, what will happen? There will be another variable which will be declared by name PTR3, which is at location, let us say 4000, and will hold address of PTR2. What is address of PTR2? 3000. Okay, so PTR3 is a pointer to a pointer to an integer. So pointer to a pointer to a pointer. Likewise, I can have 4 asterisks, 5 asterisks, pointer to a 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 pointer, and so on. There is no limit imposed by C in accessing the material this way. Okay, so I can have these kind of pointers also, because every pointer is a variable. Every pointer variable is a pointer variable. Hence, we have pointer variable, pointer to a pointer variable, pointer to a pointer to a pointer variable, and so on. Okay? So that is double pointer, triple pointer, 4 times pointer. That's the way it is used. Fine. So, any doubt in this? If no, then we'll proceed. Take a pen and paper with you. I hope every time you sit on the table attending the lectures, you are keeping a pen and paper ready with you. This is address of P. By mistake, I have written something like that, and this is address of P. This address of P and address of P. Now, this is an integer variable I. P is a pointer variable, Q is a pointer to a pointer variable, and R is a pointer to a pointer to a pointer variable. And they are initialized this way. Can you write down these values, these answers? Can you write down these answers in your copy? Just write down the answers. I'll ask one by one. I'll ask individual student. Just write down the answers in your copy. Fine. Can you know the answers now? Can I ask this answer to Praveen Pardik? What are the
Yes, sir.
values of P, Q, and R? There is no need to tell about I. I is telling. So, what are the values of P, Q, R?
PQR. Mm, 1 minute, sir. P value 500,
P value 500,
Q Q 800,
Q 800,
and R 1000.
R 1000. Absolutely correct. So everyone has got how this has happened because this is the address of I. I is at let us say that is address of our I is 500, which is given. So I write here as 500. I as 500. I value is 10. This is variable I. This is variable P. P is the address of I. Hence it will hold 500. And address of P is 800. Third variable which will be declared is Q. Q address of Q is 1000 and holds address of P. Hence it will be 800. And one more variable that is R. Uh, Let us say that it is 1200 and it is holding address of Q. Address of Q is 1000. Hence it will be 1000. So this is absolutely correct. These first three answers are right. Next, can I get the answer from Rahul Mishram? Rahul Mishram.
Yes, sir.
What is the
1 minute.
answer for this? Rahul Mishram, what is the answer for this asterisk P?
Sir, pointer P.
You are not audible. Please put it in the chat box. You are
Sir,
not audible.
pointer P answer is 10.
You are not audible. Please put it in the chat box. आपकी आवाज कट रही है बहुत राहुल. राहुल आपकी आवाज कट रही है. आप चैट बॉक्स में डालो. Rutvik Raut.
Yes, sir.
Yes. What is the answer for this?
Sir, 800.
Yes. What is the answer for this? 800.
Sir, 800.
Value at P is 800. Does everyone agree or anyone has a different answer?
Oh.
Rahul Mishram, you put your mic off. Rahul Mishram answered as 10. Rahul, you also put your mic off. Rahul Mishram answered 10. So, what is the correct answer? Can anyone else let us get it from
Sir,
Sebi?
10.
10.
Okay, someone answered. 10. 10 is the correct answer because 800 is the address of P, not value at P. Read it as value at P. What is value at P? P is 500 and value at 500 is 10, not 800. So 800 is the wrong answer. Sebi, can you tell me the next one?
Yes, sir.
Yeah. What is the answer for this?
So 500.
500, that is value at Q. Q is 800 and value at 800 is 500. Absolutely right. So I'll get the answer from Shruti Gungavkar. What is the
Yes, sir.
what is the answer for this?
Districts are 800.
800. It's also quite simple. Value of R is 1000 and value at 1000 is 800. Can I get answer from Sneha for the next?
Yes, sir.
Sneha, अगला आंसर क्या होगा?
10.
10. Value at Q.
Yes, sir.
So it will be value at Q. We'll put a bracket in front of this. Okay, so value at Q. This Q is 800. Q is 800. Value at Q is 500. So it is value at 500. And hence it is coming out to be 10. You are absolutely right. Tanmay Masurkar,
Yes, sir.
you have not joined with official ID. Next time you are supposed to do it. What is the answer for this?
10.
It will be 10 because we are just putting a bracket. So value at R is 800, then value at 800 is 500 and value at 500 is 10. So looking out to be simple. Tanmay Maske.
So 500.
What? It will be 500. So yes, this pointer seems to be easy for task for you. I'll post this PPT on the Moodle website. You please go through that, and I expect if you have some doubts, you do ask me in the next lecture, because unless until those doubts are clear, you won't be able to proceed further. So take care of that, and today we will stop here. Any doubts till now? It is anything you want me to make clear, or if you don't want, you can leave the meeting. The class is over for today. Thank you very much. You can leave the meeting.